Hello, in this video I will talk about wood and its basic properties, formability and workability. Let's first look into the richness and formability of wood. Thin wood, like veneer, has a very high elasticity. It is strong but not stiff. Unfortunately, there aren't any design methods to capitalize on this elasticity, because the elastic shape is something you cannot geometrically capture. It is something that you have to actually calculate or compute. That's why there are only very few examples of how the elasticity of a timber has been employed on a larger scale. The form finding happens during actual construction. As you can see in this temporary pavilion, built in Hyde Park, London in 2016 by Barco Leibinger Architects. This marvelous stage design looks very curvy, but the timber stairs are not shaped themselves, but consist of stacked CLT plates. Nowadays, there are a variety of new ways of machining wood. The integration of computational design and the robotic fabrication process can give architectural expression to the characteristic of the underlying wood. In forming a curved component, you can take advantage of the fact that wood is anisotropic. Most of the cellulose fibers are oriented in one direction. A piece of wood is almost 10 times stiffer in the direction of the grain than perpendicular to the grain. Hygroscopicity, the property of absorbing and desorbing moisture, means that the cellulose microfibrils actually absorb water molecules from the atmosphere. In this process of absorption, they can swell up to 10% in the tangential direction. For example, in the case of beech. There's hardly any expansion in the long direction though. This causes timber pieces to spring, bow, cup and twist, which we normally try to avoid. That is why 71% of the energy in the wood processing chain goes into kiln drying. So we dry a piece of wood, reduce the moisture content to 8 to 12%, and hope that in the service condition we can keep it there so that no shrinking and swelling occurs. But we can also use this property to do just that. Another example from nature to illustrate this. The pine cone is closed in a damp environment on the left and opens when relative humidity decreases to release its seeds. In the project for the Urbach Tower, the hygroscopic property of wood was used to induce the bending of the cross-laminated elements by drying them in a kiln. Not before, but after they were bonded together. Bending can also be induced through an external force. The members are then bonded to maintain the shape, either by glue or, like in this example from a recent wood workshop, by steel bolts and nuts. Another historical example is this curved truss from 1910, with bored lamellas with a mechanical bond of joists, bolts and nuts. The free span they achieved with this truss was around 20 meters. Let us now look into workability. Timber is not just an old school material. With a wide variety of processing methods available, it's an inviting playground for creative minds. Whether it's traditional woodworking or high-tech machining, timber offers endless possibilities. This has a lot to do with the diverse range of production, processing, and treatment methods available for wood. Timber can be cut, milled, peeled into veneers, glued, pressed, and joined into components of almost any length. The possibilities are extensive and offer a playground for those who like to experiment. Mass timber can be worked and crafted. using both simple hand tools and electrical hand tools. For faster and heavy-duty work, there are larger electrical workshop tools and digitally guided tools that translate computer data directly into a machining process. With every step, there is an increase in precision and speed. With more recent technological advancements like with CNC machining sawing or milling timber has become highly adaptable and versatile. This has opened up new possibilities for construction and components and systems. Moreover, advancements in computerized machining have opened up new avenues in the high-tech sector, allowing for completely new types of structures. Like the Symos Art Museum Gallery designed by Shigeru Ban architects. The CNC machining technological advancement allows for groundbreaking structures like this one that were previously unimaginable. A building site like a landscape, a simple process, weaving and bolting straight boards together to form this undulating diagrid structure that finds its precise form while it is being constructed. Almost a shame to cover it up later. Fortunately, the elegant, wavy structure remains visible in the interior.